Hi. In this particular video, we will be discussing about transformations. Now, before we actually move on to transformations, what we want to familiarize ourselves with is the parent function. Now, the parent function is the original function. So before we move on with any transformation, this is how the function would look like. So the parent function for a quadratic is y equals x squared. And as we could see over here, we're able to identify a few different things. We're able to identify the vertex, which is located at the origin, meaning 0, 0. And we also know that it follows the step pattern of 1, 3, 5, and so forth. The other thing that we should take note of is for the domain, it belongs to all real numbers. For the range, it belongs to all real numbers given that y is greater than or equal to 0. The opening is upwards and it has a axis of symmetry located at x equals to 0. So now let's move on to our transformation. When we are stating our transformations, we look at the vertex form. From the vertex form, we are given a few different letters. We're given the A, H, and K. The A represents the opening, and the opening can either be upwards or downwards. If our opening is upwards, then it has a minimum value. So as you could see, if our parabola opens upwards like this, it won't ever be below the vertex, therefore giving it a minimum value. What you guys do need to take note of is it does not give us what value it is. It just tells us if it's maximum or minimum. And likewise, when it opens downwards, it means that there's a maximum value and it won't exceed above the vertex. Now, how do we know if it's going to be moving upwards or downwards is by the positive or negative sign attached to A. If A has a positive sign attached to it, that means it's moving upwards. But if there's a negative sign attached to it, then it's moving downwards. It also tells us if it has a vertical stretch or a vertical compression. Vertical stretch means that our parent function will look thinner, and vertical compression means that our parent function will look wider. It will look thinner when the value of A is greater than 1, or if it is less than -1. In other words, if it's in both these ends over here, where the absolute value of A is more than 1, it will have a stretch. But if it's a decimal value in between -1 and 1, then it will look wider. It also tells us if there is any reflection on the x-axis. So if our A happens to be negative, then we know there will be a reflection on the x-axis. Next, we have the h value. The h value tells us the x-coordinate of our vertex, and it also tells us if our function will shift to the left or the right. Now, one thing you guys have to be careful of is in the equation itself, there is a negative over here. But that does not affect the h value. So if we had an equation that looked like y equals x minus 2, our h value over here is actually positive 2, meaning that it will move 2 units to the right. But if we had y equals x plus 2 squared, over here it's not in our transformation form. So we would need to rewrite this so it's x minus -2. So that means that our h value over here is actually -2 and it will be moving to the left. It also tells us the axes of symmetry. So as you guys could see, the parabola looks like this, and if we go down the vertex, it will be symmetrical on both ends. So the h value gives us that particular line of symmetry, which we call axes of symmetry, and that is x equals to h. And then lastly, we have the c value. The c value tells us the y coordinate of the vertex. It also tells us the vertical translation, so if it moves up or down. But over here, there isn't much of a change, meaning if we had y equals x squared minus 2, our c value here is -2, meaning that it's moving down. And if we had y equals x squared plus 2, our c value over here is +2, meaning it's going up. Now, the reason why I use these numbers is because I want you guys to look at the examples above. And I want you guys to take note of the difference. For the h value, it's inside the bracket. And whatever is inside the bracket, it's the opposite. So if we see a negative there, it means it's actually positive. Whereas when it's outside of the bracket, like this example over here, if we see a negative, it's actually a negative. And then lastly, the c value tells us the value of the max or min point. So over here, we had a that tells us if there is a maximum or minimum, and c is the one that gives us the actual value. So to recap, a couple of things that you guys would need to know is the vertex is located at hk. Our domain, which is all the numbers that x can take on, is x belongs to all real numbers. Make sure your e looks like this and not like that or like this. These over here are wrong. How you guys should go about it is make like a C and then put a line in between. And then our range is y belongs to all real numbers with the exception. So that bar that you see over there is the exception where y is either greater than or equal to. We would use this if the a value is positive or less than or equal to, and we would use this if the a value happened to be a negative. And it will be whatever the c value is, because the c value tells us the maximum or the minimum point. So I hope you guys understood this quick little transformation slide.